FastMCP 3 implements conditional rendering through reactive state binding, enabling dynamic UI updates without server round trips. The framework's declarative component model uses state-driven visibility toggles to create interactive feature flag interfaces. We're about to examine how a prefab app initializes with Boolean state values and employs if components to conditionally render alerts based on switch toggle events. The setup demonstrates FastMCP's integration with Prefab UI's reactive template system, where state changes trigger immediate view updates through template expression evaluation. From Prefab UI, components import column, heading, switch, separator, alert, if. From Prefab UI, app import prefab app. From FastMCP, import FastMCP. MCP equals FastMCP flags. At MCP, toolapp equals true. Def feature flags, prefab app. Toggle feature flags with live preview. With column gap equals 4, CSS class equals P6 as view. Heading feature flags. Switch name equals dark mode. Label equals dark mode. Switch name equals beta features. Label equals beta features. Separator. With if dark mode. Alert title equals dark mode enabled. Description equals UI will use dark theme. With if beta features. Alert. Title equals beta features active. Description equals experimental features are now visible. Variant equals warning. Return prefab app view equals view, state equals dark mode. False, beta features, false. This implementation demonstrates a client-side feature flag management system using FastMCP's reactive UI components. The pattern leverages conditional rendering with if blocks to show hide UI elements based on toggle state, creating immediate visual feedback without server round trips. The switch components bind to state variables, dark mode, and beta features, while the if components use template expressions, dark mode, to reactively control alert visibility. The design choice of client-side state management for feature flags provides instant UI feedback, which is crucial for configuration interfaces. However, this approach assumes the flags only affect UI presentation. Any backend behavior changes would require additional server-side handling. The initial state is explicitly set to false for both flags, establishing clear default behavior while allowing the UI to immediately reflect user interactions. This pattern is particularly effective for development tools and admin interfaces, where immediate visual confirmation of configuration changes enhances usability. The trade-off is that complex flag interactions might require more sophisticated state management than this simple Boolean approach provides. The implementation also demonstrates how FastMCP's component model enables declarative UI construction, where the view automatically updates in response to state changes. Let's break it down. From Prefab UI, components import column, heading, switch, separator, alert, if. Imports UI components from the Prefab UI library. Column for vertical layout, heading for titles, switch for toggle controls, separator for visual dividers, alert for notifications, and if for conditional rendering. These components enable building structured user interfaces with common interactive elements. From Prefab UI, app import prefab app. Imports the prefab app class from the Prefab UI. App module, providing a base application class for building prefabricated UI components in the FastMCP 3 framework. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol (MCP) servers. This class serves as the foundation for creating MCP-compliant server instances that can register and expose tools to clients. MCP equals FastMCP flags. creates an instance of FastMCP with the server identifier, flags for protocol handshake identification. The string parameter serves as a label visible to clients during MCP protocol interactions, but doesn't configure functional behavior. At MCP, tool app equals true. Def feature flags, prefab app. Toggle feature flags with live preview. Defines a FastMCP tool function named feature flags that returns a prefab app instance. The @MCP tool decorator registers this function as an MCP tool with app equals true, indicating it's an application-level tool. The docstring toggle feature, flags with live preview, serves as the tool's description in the MCP interface. FastMCP will automatically handle parameter validation and schema generation based on the function signature. With column gap equals 4, CSS class equals P6 as view. Creates a column layout with a 4-unit gap and applies the CSS class P6 for padding, assigning it to the variable view using a context manager. The column class here is being used as a layout container with specific spacing and styling parameters. Heading feature flags. Creates a heading titled Feature Flags in the user interface or documentation output. This is a simple display element that organizes content under a labeled section, with no functional behavior or processing logic. The exact rendering depends on the framework's presentation layer, but the line itself only declares the heading text. Switch name equals dark mode. Label equals dark mode. Creates a toggle switch UI component named dark mode with the visible label dark mode. The switch will appear in the interface with this identifier and label, allowing users to toggle between states. Switch name equals beta features. Label equals beta features. Creates a toggle switch UI component with the internal name beta features and a user visible label beta features. This is a standard UI control that allows users to enable or disable beta features through a simple on-off switch. With if dark mode. Conditionally executes the following indented code block only if the template variable dark mode evaluates to true. The if construct appears to be a template control structure that checks the value of dark mode and conditionally renders or executes content based on its Boolean state. Alert title equals dark mode enabled. Description equals UI will use dark theme. Creates an alert notification with the title dark mode enabled and description UI will use dark theme. This appears to be a user-facing notification about a theme change, likely triggering a visual alert in the interface. With if beta features. Conditionally executes the following indented code block only if the beta features template variable evaluates to a truthy value. The if context manager checks the rendered value of beta features and either executes or skips the block based on its Boolean interpretation. Title equals beta features active. Assigns the string beta features active to a variable or attribute named title. This creates a simple text label that could be used for display purposes, status indication, or as a configuration flag in the application. The exact usage context isn't visible in this single line, but it establishes a human-readable identifier for beta feature status. Description equals experimental features are now visible. Assigns a string value, experimental features are now visible, to a variable named description. This creates a simple text descriptor that could be used for logging, user notifications, or feature flag documentation within the FastMCP system. Variant equals warning. assigns the string value warning to a variable named variant. This creates a simple string variable that can be used elsewhere in the code, though its specific purpose isn't visible in this single line. The variable name suggests it might be used for styling or status indication, but that would require additional context from surrounding code.
Return prefab app view equals view, state equals dark mode. False, beta features, false.
Returns a new prefab app instance initialized with the provided view parameter and a state dictionary containing two Boolean flags. Dark mode, set to false, and beta features, set to false. The state dictionary defines initial application settings, while the view parameter likely specifies the UI component or layout to be rendered. This implementation showcases FastMCP 3's Reactive UI pattern through client-side feature flag management. The core technique combines state-driven conditional rendering with declarative component composition. Switch components bind to Boolean state variables, dark mode, and beta features, while if components use template expressions to reactively toggle alert visibility. The design creates immediate visual feedback by leveraging Prefab UI's reactive template system, where state changes trigger automatic view updates without server round trips. The pattern's effectiveness comes from its simplicity. Initial state defaults to false for both flags, establishing clear baseline behavior, while the declarative structure keeps UI logic tightly coupled with visual representation. This approach excels for admin interfaces, where instant configuration feedback enhances usability, though it assumes flags only affect presentation. Any backend behavior changes would require separate server-side handling. The trade-off between simplicity and scalability becomes apparent with complex flag interactions, which might outgrow this straightforward Boolean state management approach.
The dark mode switch flips, and the UI begins to dance under a spreadsheet of shadows.